can teach themselves to use external tools via APIs. Large language models demonstrate the abilities to solve new tasks from a few examples or textual instructions. Toolformer, a large language model-based agent, can teach themselves to decide which APIs to call, when to call them, or what arguments to pass, and how to best incorporate the results into future token prediction. The external tools include a calculator, a Q&A system, a search engine, a translation system, and a calendar. One example is shown here. Given some human written examples of how an API can be used, a large language model annotates a huge language modeling dataset with potential API calls, and then use a self-supervised loss to determine which of these API calls help the large language model to predict the future tokens. Finally, the large language model is fine-tuned on the API calls that it considers useful. A large language model is trained to have the ability to use different tools through API calls. API calls are represented as tuples Z, where AC is the name of API and IC is the corresponding input. Given an API call C with the corresponding result R, the sequences EC and ECR of API call without and with the result are denoted as here, where API/API and error are special tokens. Given an input text X, we first sample a position I and the corresponding API call candidates from CI1 to CIK, and then execute API calls and filter out all calls that don't reduce the loss ARI over the next tokens. All remaining API calls are interleaved with the original text, resulting in a new X asterisk as shown here, step by step. For each API, a prompt P encourages the large language model to annotate the example X with the API calls. An example of prompt P for a Q and A2 is shown here. Suppose that a P LLM is a probability that the large language model assigns a token Z plus 1 as a continuation of the sequence from Z1 to Zn. The input X is the sampled key candidate positions for API calls by computing the probability Pi that the large language model assigns a API call at a position Pi. Given a threshold tau s, the positions capital I defines a candidate set. For each position I, M API calls are sampled given the sequence here as a prefix and the /API as the end of sequence token. All API calls generated by large language model are performed by calling another neural network, executing a Python script, or using a retrieval system to search over a large corpus. Suppose that I is the position of the API call CI in the sequence X, and RI is response from the API call CI, give a sequence of weights WI and a prefix sequence Z. The weighted cross-entropy loss LI for large language model over the tokens from X1 to Xn is defined as here. Suppose that epsilon is an empty sequence to different losses, L plus and L minus are defined as here. Giving a filtering threshold tau f, only API calls satisfying the condition here are kept, namely the API call reduces the cross-entropy loss by at least tau f. The responses of remaining API calls are interleaved with the original inputs, namely the new sequence X asterisk is constructed, where X is input and E is the result of the API call at position I. API calls are performed on all inputs X so that a new dataset C asterisk is obtained, which is augmented with API calls. The dataset C asterisk is used to fine-tune the large language model through standard language modeling objective. Apart from the inserted API calls, the C asterisk contains the exactly same text as the original dataset C. Fine-tuning the large language model on C asterisk exposes it to the same content as fine-tuning on C. When API calls are inserted in exactly those positions and with exactly those inputs, that helps the large language model predict the future tokens. Fine-tuning on C asterisk enables the large language model to decide when and how to use which tools based on purely on his own feedback. When generating text with a fine-tuned large language model, a regular decoding is performed until the large language model produces the error token, which indicates that it expects the response for an API call. At this point, we interrupt the decoding process, call the appropriate API to get a response, and continue the decoding process after inserting both the response and the /API token. For more details, please check with these references. Thank you. Bye.